Welcome. Many claim that solar activity affects our weather and climate. Some even believe that earthquakes and volcanic eruptions are caused by the sun. These are all myths. Many people on social media are out to mislead you on this issue. Here are just a few of them. They're often out to solicit donations or sell you copies of their latest crummy book, or to sell you coffee mugs and t-shirts, things of that sort. As I say, it's a myth. Flares on the sun do not have enough energy reaching the Earth to make a difference to our weather. Coronal mass ejections produce even less energy reaching the Earth. Solar wind, less again. So none of these sources have enough energy to affect our weather, which takes an awful lot of energy to change. The sun does affect our climate over billions of years, as I'll explain later. But it does not affect earthquakes or volcanic eruptions either. So if you hear any of these myths being propagated, you know that you're trying to be scammed. The origin of the myth was Sir William Herschel, the Astronomer Royal at the time, and also the discoverer of the planet Uranus. He claimed he made money investing in wheat grain prices based on the number of sunspots on the sun. And this has been propagated over the years as proof that the sun affects our weather. His argument was quite simple. Sunspots are dark, so they are cooler. That would then lower the temperature on the Earth when there are lots of sunspots on the sun. That causes crop failures, and so wheat prices go up. It's quite logical, really, except for a few problems. Unfortunately, he got it 180 degrees wrong. When the sun has the most sunspots, it is hotter, not cooler. You can see here at the top plot, we have a plot of the total solar radiance, that's the amount of energy coming from the sun and reaching the Earth. It peaks at about the same time as the number of sunspots. Now this doesn't make sense unless you know about something called faculae. These are these bright areas on the sun that surround sunspots and cover the whole disk of the sun. And they actually make up more than the deficit from the sunspots. And so the sun actually produces more energy when there are a lot of sunspots around. But of course, the theory might work in the opposite way. So let's take a look at that and see if that is in fact the case. Well, let's test his theory. Here is the number of sunspots from 1960 to the present day in red, and in blue, the price of wheat. Now, if his theory was correct, then when the large number of sunspots there, you should have a peak in the prices of the wheat, and when the sunspot number is low, you should have a dip in the prices of wheat. And you can see there's no particular pattern there. Well, let's take the opposite of that theory. As there's no pattern, then when there's a lot of sunspots, there should be more energy, so we should have a dip. And when there's less energy, we should have a peak. Here's solar maxima, and you can see there's sometimes it's low, sometimes it's high. So there is no correlation here. This also, by the way, negates the galactic cosmic ray cloud theory, because as the sunspot number increases, you should get more magnetic field in the interplanetary space, fewer cosmic rays, fewer clouds, so higher temperatures, and an increase in the amount of wheat that's available, so a decrease in the price. And as there is no such pattern, then that negates that theory as well. We can go one better. We can do a correlation plot between the sunspot number and the price of wheat. And as you can see here, it's basically a scatter plot. There is no pattern whatsoever. The correlation coefficient for this is minus 0.24. That's at best, it means it's anti-correlated. A correlation coefficient of less than 0.7 or 0.8 means there is no correlation at all. And that's in fact exactly what we have here. So either way, this doesn't work. There have been many other studies by scientists looking for such linkages. The link between weather and sunspots, the weather and flares, and the weather and coronal mass ejections. And to date, none has been found. And even if there was some sort of correlation, that doesn't prove anything. That doesn't prove causation. Looking at the sun and earthquakes, statistical studies do not prove a causation. You can get some very weird causations. In fact, I would actually advise you to go look at weird correlations. Here's one, for example: US crude oil imports from Norway versus the number of drivers killed in collisions with railway trains. Almost perfect correlation. But none has been found to date. One popular hypothesis is that the magnetosphere gets filled up with protons, and this causes currents induced in the mantle of the Earth, which creates the piezoelectric effect, which causes earthquakes. There is no such link shown. The amount of energy involved is minuscule, and the piezoelectric effect is absolutely tiny. Similarly for the sun and volcanoes. Now, volcanoes do affect our weather and climate by cooling the atmosphere when they erupt by putting aerosols high into the atmosphere. But there is no 11-year cycle in volcanic eruptions. The correlations are weak and no proof of causation. You can see the plot on the right here doesn't look particularly convincing. And there's no known physical mechanism by which you can link solar activity to volcanic eruptions. So even in the best of cases, there's not really very much of a case to answer here. So what can we conclude from all of this? Solar activity does not affect our weather in any significant way, nor does it cause earthquakes or volcanic eruptions. The sun does affect our climate over the very long term, in that as the sun evolves along the Hertzsprung-Russell diagram, it becomes steadily warmer and eventually dives off of the main sequence to become a red giant, then produces a planetary nebula and decays away to a white dwarf. Now, we don't have anything particular to worry about this at the moment because it'll be another billion years before the sun becomes hot enough to affect us such that we start losing atmosphere and water from the Earth. So we've got a billion years to solve this problem. Once it becomes a white dwarf, the sun could last 100 billion years after that, though we and the planet Earth probably won't be around to see that. So thank you for watching. Until next time, stay safe and goodbye.